Okay, here we have an example of one of the tricks of integration by parts, and that is in which we do a little mini substitution to get started. If you try doing this other ways, you might try simple substitution or simple integration by parts, you'll see that you get kind of a confused mess. But if we try a substitution in the beginning and then integrate, it gets easier. I will demonstrate. Let's call it t. Let t be equal to the square root of x. All right, so then dt is going to be 1 over 2 radical x dx. Then if we go and start substituting, we'll see that we get the integral of the cosine of t. But then when we go to sub for dx, we've got a kind of a problem. So if we multiply both sides by 2 radical x, we get 2 radical x dt equals dx, but remember that's radical x is just t, so we get 2t dt equals dx. So when I put this out front, 2t, and then get myself into dt format, I can then integrate this by parts. So here is our algebra part, and here is our trig part. So if we consult the oracle of Lie8, where we've got logs, then inverse trig, then algebra, then trig, and then exponent. If we do that in order, that way, we find that we're going to start with our a bit, and we'll let u be equal to t. I'm just going to take the 2 and bring that out front, all right? In fact, I will write that right now and scribble it out. So if u is equal to t, then du is dt. I like this little chart here, so I'm going to go down that way, and then I'm going to come up this way. So I write then dv is equal to cosine of t dt. Well, to work upwards, then we have to integrate to get v. V then is equal to, well, the derivative of the sine gives me the cosine, so I get that. And then remember, our little formula for integration by parts is that when we get it into this format, this integral is going to be equal to, I'm not forgetting the 2, that's the easiest thing to do, 2 times, and then it's uv minus the integral of v du. All right, well, uv is just t sine of t minus then the integral of the sine of t and then dt. All right, so I can integrate that easily enough, and I wind up with 2, well, t sine of t, let's just go back and make our substitution now. Radical x sine of radical x minus the integral of sine is the minus cosine, but I'm subtracting it, so this just becomes plus cosine of radical x, and then I'll do out plus c out there. Okay, so there you go. It's as straightforward as that. Try taking the derivative, and you'll see that here you've got a product rule, and the second part of the product rule then we'll cross out with that, and the 2 will make it all exactly what we'd want it to be up there. Okay, works out rather nicely. Thank you.